Somewhere, an advertiser just paid for 1 million app installs. The dashboard looks beautiful, a clean line climbing all day. 1 million new people who tapped an ad, downloaded the app, and opened it. The cost per install came in right on target. The campaign looks like a success, and the budget for next month gets approved on the strength of that line. Here's the quiet problem. Most of those people were always going to install the app anyway. They saw it in the store. A friend mentioned it. They searched for it by name. They were on their way to download it with no ad involved at all. And at the last possible second, something stepped into the path and claimed the credit for sending them. The advertiser paid full price for 1 million users they already had. That is the heart of mobile install fraud. And it is one of the strangest corners of the whole ad economy. Because the fraud is not always about fake people, sometimes it is about real people whose actions get quietly stolen. How an install gets paid. Start with how app advertising pays, because the whole game grows out of it. An advertiser does not just pay to show an ad. They pay when someone installs the app after seeing it, and often they keep paying for what that person does next. So the chain has stages. An ad is shown. Someone taps it. The app store opens. The app installs. The person opens it, maybe signs up, maybe buys something. Each of those later actions can carry its own payment, because a user who actually spends money is worth far more than one who installs and vanishes. That means every install and every action after it is a number that triggers a payout. And anytime a number triggers a payout, there is a reason for someone to make the number appear without the real thing behind it. This model exists for a good reason. Advertisers got tired of paying for views and clicks that led nowhere, so they pushed the payment further down the chain, toward things that looked like real outcomes. An install is a real person choosing to put your app on their phone that feels solid in a way an impression never did. The trouble is that solid-looking outcomes are also the most valuable ones to counterfeit. The attribution question. Here is the part that makes mobile different. When an install happens, the system has to decide who gets the credit. There might be 5 different ad networks all showing ads for the same app. When the install finally lands, which one earned it? And stuff and that is called attribution, and it is handled by a neutral middle layer, a measurement company that sits between the advertiser and all the networks. Its job is to look at the install and say, this person tapped that network's ad first or last, so that network gets paid. The most common rule is simple. Credit goes to the last ad the person touched before installing. Last click wins. It sounds fair, and for honest traffic it mostly is. But that one rule, last click wins, is the seam that almost all of this fraud preys open. Stealing the last click. Think about what last click wins actually rewards. It does not reward the network that convinced you. It rewards whoever was standing closest to the install at the moment it happened. And that is a position you can fight to occupy without convincing anyone of anything. So the central idea of attribution fraud is not to create installs. It is to make sure that whenever an install happens, for any reason, your fingerprints are the last ones on it. You do not need to drive a single real download. You just need to be the last click on the record for downloads that were going to happen anyway. The measurement layer is looking for a click followed by an install. The fraud's whole job is to manufacture that click, position it right before the install, and let the real user do the actual downloading. The credit and the money follows the click. Click flooding. The bluntest way to do that is called click flooding. The idea is to fire an enormous volume of fake clicks for a huge number of devices in the hope that some of those devices were going to install the app on their own. For the vast majority of people, the click is wasted because they never install anything. But for the small slice who were already on their way to downloading that app, the fraudster's spray happened to include a recent click for that device. So when the real install lands, the records show that fraudster's click was the last one before it. Last click wins, and they collect. It is a numbers game built on patience. The operation only needs to be holding a recent fake click for a device at the exact moment that device installs and at a large enough scale that overlap happens constantly. The tail click flooding leaves. What makes click flooding catchable is that it ignores the actual user completely. It is firing clicks blindly, so there is no real relationship between the click and the install that follows. That shows up in the timing. For a genuine ad, the gap between tapping the ad and the install finishing tends to fall in a fairly natural band, a couple of minutes while the store opens and the download runs. Click flooding produces a wild spread instead. Enormous numbers of installs that happen many hours, even days, after the supposed click, simply because the click was random noise that happened to land before a download. It also shows up in conversion rate. A network sending millions of clicks but earning credit for only a tiny fraction of them is behaving nothing like a real ad source. Real ads convince a meaningful share of the people who tap them. A flood converts almost nobody because almost nobody tapped on purpose. Click injection. The more precise version is called click injection, and it is the same theft done with much better timing. Instead of spraying clicks and hoping, it waits to detect that an install is actually starting on a specific device and inserts its fake click into that exact moment. On a phone, other software can sometimes notice when a new app is in the middle of installing. An operation positioned to see that signal can fire its click in the narrow window after the download begins, but before it finishes. The click lands a few seconds before the install completes, which to the measurement layer looks like the perfect, most convincing case of all, a tap immediately followed by an install. It is the difference between a pickpocket who bumps into everyone hoping to find a wallet and one who waits until he sees you reach for yours. How injection gives itself away. Ironically, click injection is often easier to catch than flooding, precisely because it is so well timed. It produces clicks that land suspiciously, impossibly close to the install completing, again and again. Real users do not install apps in seconds. There is a store page, a tap to download, a wait while it transfers, then the install. A network whose clicks consistently arrive in the final breath before completion with almost no natural variation is showing a pattern human behavior never produces. The very precision that makes injection effective is the thing that exposes it once a defender knows to measure that gap. So the same signal, the time between the click and the install, catches both. Flooding shows gaps that are far too long and random. Injection shows gaps that are far too short and consistent. Honest traffic sits in the messy human middle. Then there is the most direct fraud of all, where the install itself is fake. No real user is involved. The install is produced by a machine, either a rack of real phones run as a farm, or software emulating phones that do not physically exist. Device farms use real handsets, installing apps, opening them, going through the motions, then wiping and doing it again. Emulators skip the hardware entirely and pretend to be thousands of phones in software on a single server. Both exist to generate installs, and the more sophisticated ones go further, faking the actions after the install too. The signups and the in-app events that carry the bigger payouts. This is the most expensive fraud to run and done carelessly, the easiest to spot, because a fake device has to convincingly impersonate a real one in every detail an ad system might inspect. The tells a fake device leaves, emulators in particular, tend to leave traces. A software phone often gets small things wrong about the hardware it claims to be, sensors that report impossible or perfectly static values, a device model that does not match its other characteristics, a graphics signature that belongs to a server and not a handset. Device farms are harder because the phones are real, but scale betrays them. Thousands of devices sharing the same narrow range of network addresses, the same handful of models, freshly reset over and over with no real history, all behaving in lockstep. A single farmed phone can look ordinary. Thousands of them moving together do not. And then there is what happens after the install. A real user opens the app, taps around, comes back the next day or never, in the messy way real people do. Fake installs tend to open the app once to register, then go silent forever, or perform a flat, scripted imitation of engagement that looks nothing like the irregular rhythm of a genuine user. Behavior after the install is often the clearest line between a real download and a manufactured one. How detection actually works. Put the defensive side together, and it comes down to a few questions asked of every install. How long was the gap between the click and the install? Does this device look like real hardware? Does the network it came from behave like real users? And what did the person do after they opened the app? The timing between click and install catches the attribution thieves, flooding with its long random gaps, injection with its impossibly short ones. Device fingerprinting and emulator tells catch the fake hardware. Network reputation catches the farms clustering on the same addresses, and behavior after the install catches everyone. Because faking a real person's ongoing use is the hardest thing of all to sustain. None of these is perfect alone. A clever operation can beat any single check. Spread the farm across more network addresses and the clustering fades. Add natural-looking delay and the timing improves. But beating all of the checks at once, on every install, at the scale that makes fraud worth running, is genuinely hard. The more convincing each fake install has to be, the more it costs to produce, and the thinner the profit gets. So the defensive game is less about one perfect detector and more about stacking enough imperfect ones that the cost of looking real everywhere outruns the reward. An install that fails several of them at once gets thrown out and never paid. The measurement layer is in the end just trying to answer one question for every payout. Was there a real person here who a real ad actually moved? Why this fraud is so hard to kill? The reason mobile install fraud is so stubborn is that the best version of it hides inside real activity. Click flooding and click injection do not invent users out of nothing. They attach themselves to genuine installs that were always going to happen and skim the payment for them. That makes them far harder to see than a crude fake because the install is completely real. The only thing that is fake is the claim about who caused it. You are not hunting for a counterfeit. You are trying to prove that a real event was credited to the wrong source, which is a much subtler thing to catch, and the incentive never goes away. As long as being the last click before an install is worth money, there is a reason to fight for that position by any means, honest or not. The measurement layer improves, the fraud adapts, and the loop continues, because the prize at the center of it, that last click, keeps paying. The rule underneath all of it, step back and the specific tricks matter less than the shape they all share. An advertiser wanted to pay for results instead of guesses, so they tied their money to a number, the install, the action, the last click before it. It was a reasonable thing to want, but the moment a number triggers a payment, that number stops being a neutral fact and becomes a target. Someone somewhere will build a machine whose entire purpose is to make that number appear without the real thing it was supposed to represent. That is the pattern under all of it, and you will find it everywhere money meets measurement. Wherever a counted event triggers a payout, the count itself becomes the thing to fake. The install was just one more number that paid, so someone built a machine to produce it. If this kind of breakdown is your thing, subscribe and follow the rabbit hole. Once you start seeing the world as numbers that trigger payments, you start seeing the machines built to fake them everywhere. Next time, we follow a single stolen password as it travels. One breach somewhere you barely remember, tried automatically against 100 other sites until something opens. That one is called credential stuffing, how one breach unlocks 100 sites.